All right, class. In this video, we begin section 4.1, part 1 in your textbook. It has to deal with right triangle trigonometry. We're going to take the definition of the 6 trigonometric functions of theta and apply from section 2.2 and apply them to right triangles. If you had any right triangle trigonometry in high school, you might find this a bit of a review. Here on the diagram on the right is an example of a right triangle, and the distinguishing feature of a right triangle is that one of the angles has a measure of 90 degrees. And so the little square in the right hand corner, right, indicates that this leg, the two legs of the triangle, form a 90-degree angle, which we call a right angle. The side opposite the right angle is called the hypotenuse. The other two angles are labeled A and B in this right triangle, and A and B are both acute angles. That means that their measure, the measure for each of those angles is between 0 and 90 degrees. The side opposite the right triangle, or the right angle, excuse me, is called the hypotenuse. And A, B, and little a, little b, little c represents the lengths of the three sides of the right triangle. In every triangle, the three angles have to add to 180 degrees. So that means the two acute angles, A and B, have to add to 90 degrees. And lastly, by the Pythagorean theorem, a squared plus b squared has to equal c squared in a right triangle. Down below is an example, another example of a right triangle, except instead of this angle being labeled with the letter B, it is labeled with the Greek letter theta. And the three sides, right, lengths of the three sides are A, B, and C as up above. Right, the hypotenuse is still across from the 90-degree angle. The side, the leg that is next to angle theta, we call that the adjacent side because it's adjacent to theta. And this leg of the right triangle we call the opposite side because that leg is opposite the angle theta. And the hypotenuse is always opposite the right angle.